welcome to Map to the Future. Today, we're looking at the final frontier, space. And we're asking the question, how close are we to actually exploring space as an interplanetary species? Is it as close as people like to think or hope, or is it in fact far further away than we might ever think? The problems that we get with space travel are vast. It is hugely more complex than diving into the depths of the oceans. It is hugely more challenging and more expensive than any other undertaking in history. And yet, if you listen to the people who are its greatest proponents, they will tell you that it is absolutely essential to the next step of humanity. Today, I welcome guest Sam Ximenes, who runs a company based out of San Antonio, Texas, that are designing and developing the equipment and the resources required to build bases on the moon and on Mars and beyond. And we are going to dive into some really fascinating subjects and really fascinating understanding and ideas of how we can even start to try to achieve interplanetary travel. Is space the next frontier that we will see broken in our lifetimes? Or is it still just the final one that humanity is still centuries away from achieving?
But anyway, we got there in the end. Technical issues hit us both there. It was very, very irritating, but we got there in the end. Good to see you. How are you?
I'm doing well, thank you. Yes.
Excellent. Well, welcome to the Map to the Future podcast. Thank you for joining us. One thing that I've got to go grab and show you that you will get as a result of joining us as a guest. After the episode, you'll send me your address, and we will send you the Map to the Future mug.
Right.
So it's the official printed merchandise mug that will get sent across to you. So you only get those if you come on as a guest. So you'll be in a very small select group of people so far.
All right, looking forward to it.
Yeah, good. So Sam, tell me, let's kick off by telling everybody who you are. What is who is Sam Ximenes? What do you do? What is it that you're doing at the moment in the world?
Sure. So I am Sam Ximenes. I'm a space architect. I've been doing it for a good 30 plus years. Started from way back in these constellation days, even space station when it was on the drawing boards, the International Space Station.
Yeah,
in the habitation, crew quarter designs and galley designs, and how does an astronaut live in space for the first time? They were living in large volumes.
Okay.
How do they get around? In a multi-volume module type of configuration. Then we started doing lunar-based planning and design back in the even before constellation.
Okay.
So NASA did a number of starts and stops on their plans for going back to the moon. For the most part, I do space architecture for lunar surface applications.
Okay.
In addition to that, we do space architecture for spaceport applications here on Earth.
Okay.
So we've been involved with a number of commercial spaceports. Virgin Galactic spaceport up in New Mexico, the Spaceport America, Houston Spaceport, another one. We did some assessments for the UK spaceport site selections as well, and plus some ongoing ones we have also with the Transportation Command, a number of other projects. So that's my background. So I'm an architect and became a space architect.
Okay, so what's the difference between, say, a terrestrial architect and a space architect? Is it basically the same thing? You're just designing for space, or are you actually planning and using the engineering side of it as well? How does that? What's the difference?
More engineering side of it.
Okay.
You know, the same principles of architects have an end-to-end system approach. They know the big picture of the concept of the building and the, you know, all the pieces of that. Same thing here. The closest analogy to the engineering side are systems engineers.
Okay.
The space architects take on a little bit more of a human factors piece of it involved, more master planning type of stuff.
Okay.
You know, and then the materials that go into building and construction.
Amazing. So I suppose that what I'm really interested to talk about here is that obviously, you know, space is being viewed very much as the sort of the you know, the next frontier of human exploration. We've kind of explored most of this planet, although there's still the statistic about we knowing less about the bottom of the ocean than we do about the surface of the moon. But we've explored most of it. We've found pretty much all the land in it, most of the things about it, and so on. But now, you know, a lot of human exploration looks to the skies and is looking to the moon, is looking to Mars, and things like that. So, I suppose my immediate question is, how far from, you know, interplanetary human travel do you think we are?
Oh yeah, we're decades away.
Yeah.
I mean, if you'd be interplanetary by between here and the moon, well, of course, we've already done that.
Yeah.
But you know, between the moon and Mars, you know, we're still decades before we get there.
Yeah.
The next step is to get back to the moon so that we can start doing that interplanetary travel. Use the moon as a proving ground. Use the moon for fuel, you know, resource extraction, and then be able to get to Mars a bit easier.
Yeah. So am I right in understanding that the plan is to actually launch the next sort of Mars missions from the moon, because there's a lot less you know, fuel required to launch off the moon than there is launching off the Earth, for example?
Yeah, that's the general consensus, is that if you can launch from the moon using resources, fuel derived from the moon, with the water that's there, and fuel depots that would be established, and you know, essentially have a gas station in space around the moon, lunar system or space, and then you have, it's a little bit easier to transit because of the you know, it costs a lot of money and a lot of weight to bring all that fuel. You got to do, you know, even the Elon Musk SpaceX architecture for getting to the moon, he's doing fuel transfer, just to get to the moon of that big cargo ship as well.
Yes. Okay. Fantastic. So the question, you know, that I'm really keen to explore here is the realities of exploring space, because our channel and a lot of the people that follow it and so on are loosely in the slightly conspiratorial space, a lot of them, and there's a lot of people that believe that space travel isn't actually possible, and that the moon landing never took place and things like that. So I suppose what I'm more interested to understand is what are the actual realistic constraints to getting to Mars, for example, because I mean, I'm somebody that you know, I basically understand you know, space and space exploration from a fairly low level understanding, but even I'm kind of the awareness that, you know, you don't, it's not like Mars is next door. It might be the next planet, but it's not next door. You know, our orbits are not in sync, so quite a lot of the time it's round the other side of the sun to us, and we've got to wait for it to be closer to alignment and things like that. So what are the constraints that make it decades away from us getting to Mars?
Well, the biggest one is the radiation regime you're going to experience over that journey, whether it's 6 months or 2 years. I mean, the closest conjunction is a 6-month journey, but still, that's a long time. And this is right now, the space station astronauts are protected still by our magnetosphere. You know, there's still some protection from there. But once you get into deep space, there's galactic, you know, radiation that's much more intense.
Yeah.
So that's one of the bigger things. Even something as, I won't call it simple, but as basic as food consumption. how do you keep food stores for that, for that period of time, and especially if doing the longer journeys, if you're not waiting for the conjunction, and then the human factors, the ability for the crew to stay in one, confined in small quarters for a period of time. Just some physical things that go into it.
Okay.
Into that journey, just the journey part. Okay?
Yeah. So you mentioned the radiation.
Not alone getting there and landing.
Yes, and let alone getting back. So you mentioned the radiation element. This is something that gets brought up quite a lot, and I hear about this quite specifically. Now, you mentioned a particular thing there that the space station is protected by the Earth's what was it? What did you call it?
The magnetosphere.
Okay.
It's essentially the magnetosphere and the influence of the atmosphere is not just at the boundary of Earth. It goes out to some distance. Okay, so we still have it gets less and less as you go further out.
It's effectively the Earth's magnetic field.
Yes. Yeah.
Okay.
Exactly.
And that forms an effective kind of electromagnetic protection from space radiation.
Yeah, but not as, it's pretty not as protective as you were standing on the Earth, right? It's
obviously the closer to Earth you are, the more protected you are.
Yeah.
Okay. So sort of the further into the field you are, the more protection it's giving you.
Correct. Yeah. Okay. And the astronauts are, they're at the outer edges of it, and that they still have lifetime doses that they have to deal with, they deal with in terms of how long they stay up there as well. So.
Okay.
So you got also other things that go into it. I mean, if you're not on that journey, you're still in microgravity, right? So you got to deal with all the other physiological occurrences that we're finding out from this long-term stays in the space station. Bone mass loss.
They get muscle atrophy and all kinds of other things.
All that kind of stuff.
Yeah, because you're not using the same amount of muscle mass as you would to walk around on Earth, because you're floating around most of the time. You're not your muscles, especially if you're there for 6 months, your muscles and your bone densities and everything starts to atrophy. So how are they looking to solve those kind of problems?
Well, right now the biggest countermeasure is exercise. That doesn't really. I mean, that's the kind of go-to solution at the moment, but that's not sufficiently enough to they still come back with the difficulty walking when they land, those kind of things.
Yeah.
There's still a lot of research being done for medical interventions of some sort, maybe some sort of I don't want to call it a pill, but some kind of medical situation where you can mitigate.
Okay, so something they would give them that would that reduce the amount of atrophy, reduce the bone density loss, all that kind of thing.
Yeah.
Okay.
Yeah.
Okay. And obviously,
I don't think they have all those. None of that's all solved.
No, I don't think it is. And whenever you watch science fiction, the answer always seems to be that what you do is you have some sort of device on the ship that generates a mimicked gravity to Earth.
Yeah, right. You make the assumption that got gravity already solved somehow.
Exactly. Yeah. And I mean, is that a solution that anyone's exploring? Are they exploring ways to artificially generate gravity?
Yeah, there are people that are looking at the centrifuges, essentially, integrated into and you see some of the science fiction shows where they have it rotating the
so it spins to create the centrifugal force to mimic the gravity.
Yeah. Okay. But I don't see anything being done seriously. I mean, those are just all of that. Yeah, I don't see any commercial guys or anybody in the industry trying to really build something like that right now.
Yeah, because I suppose the problem in that is scale.
Yeah, yeah, exactly.
Because in order to get something that's large enough and spin fast enough to create a gravitational field that would be similar to Earth, it needs to be quite big, and there's probably a lot of energy involved in actually getting it to start rotating in the first place and maintain the same speed of rotation and everything else. I suppose there's a lot of stuff in it.
A lot of stuff that goes into it. Exactly. I mean,
Okay.
just putting the centrifuge. I mean, there was supposed to be a centrifuge on the space station at one time, and they took it out of the program. Not a centrifuge for gravity, but a centrifuge for science research, a small one.
Okay.
That would go into a rack, and they took it out because it was perturbations of it was causing the vibration throughout the whole station.
Yes.
And so it never got put in. So
yeah, and that wasn't even designed to create gravity. That was just a centrifuge of some sort that was supposed to that had another purpose. But because of the continual movement of it, that was going to cause potentially structural issues throughout the rest of the space station.
Right. Exactly.
Yeah. Okay. So I think that I find it really fascinating that space is the logical next frontier of human exploration, but we are probably in the absolute embryonic stage of how far we can take that.
Yeah, well, you think about this next Artemis 2 mission, finally going to get humans back in space, in deep space, they call it. That's really is deep space because it's outside of
it's still within the magnetic field, basically.
Well, when you get to cislunar space, you've gone past that. When you get around the moon.
So once you get to the moon distance, you're outside of the magnetosphere.
Yeah, although there's some studies that says that there's something that I saw somewhere. There's the Earth's atmosphere does extend somewhat to the moon in some sort of granular level. I don't know how far what the connection is, but there are some studies that says there's Earth influence. Anyway, the astronauts are going to be there, in deep space for just a circle flyby.
Yeah.
Right. And that's as far as we've gone.
Yeah, which is and the way that I've heard it explained is that it's a bit like the equivalent of the first people crossing the Atlantic, kind of walking up to their waists in the beach. That's kind of that's about as far as we're really realistically getting as far as deep space is concerned. I mean, do you think that analogy is about accurate, or would you have a different way of looking at that?
Still think about it. I mean, they actually landed on in the Apollo days, they actually got on the ground, so they got out of the water, right? They got onto the surface. Yeah. So we've been on the surface, right? We've done it. Okay, we've done that before. Yeah. Now we're going 50 years later. We're going back to try to do it again, and so we're doing it. We're seeing how the water is again.
Yes, yeah, testing the water again, as it were, because there was obviously a further exploration where they go, okay, there is something there, but getting there is the key thing. So one of the things that I know that you guys are working on at the moment is a lot of the architecture around a moon base focus. So what is the primary intention of a moon base first of all? So
the idea for and I don't call them a base, I call it a camp, an outpost. It's a camp at this point in time. Eventually we'll get to the base, a full-blown base with infrastructure and all this. But in the beginning, you're going to have an outpost, a basic camp situation. You probably won't be able to stay there more than 7 days, at the most, a month at a time, just because of the consumables and the resupply requirements, all that. And then you're doing the construction piece of it. And one of the rationales for going back to there and for settling is the resources that are on the moon. Again, this what we talked about earlier. The resources are the regolith, the water that's been discovered.
Yeah,
and not only that, there's helium-3. There's all kinds of other minerals that could be extracted, and the rare earth metals as well. So it's really going to be a mining camp, in my opinion, that would be set up essentially. Of course, the scientists will be there too, doing their scientific and exploration type stuff. But for the most part, commercially, it'd be for mining.
Okay. And
setting up the camp for that.
Yeah. So mining being the kind of the commercial element of it, they can make money from the moon base by being able to mine the rare earth metals that are on the moon. And I suppose you'd call them rare moon metals in that sense. They're not technically rare earth metals anymore.
Rare moon,
rare moon.
I think mostly the biggest one is the helium-3 that they want to extract.
Okay.
But the other part is, of course, is the water. Okay, because the water turns into fuel.
Yeah. What do they use helium-3 for?
Helium-3 is going to be used for fusion reactors once they become online, but also there's a lot of medical imaging that it can be used for a lot of the other different industrial processes.
Okay.
So there's a big market that I think that what's the company called? Interloon just raised it $20 million. Not just, I guess last year they raised $20 million to mine helium-3, and that's probably going to be probably the first export back from the moon and brought it back into the Earth for use of here on Earth, because there's a market for it here on Earth, right?
Of course. So do we get helium-3 on Earth as well, or is it only?
It's very rare. It's not in abundance at all. It's hard to come by. So especially for the quantities that are going to be needed that they're projecting for for AI data process, things to go into quantum computing and medical imaging. All these things are useful applications of that would be more advanced with helium-3.
Okay. And so is helium-3 is it more like a fuel, or is it functioning more like a metallic substance? I mean, how does helium-3 actually look? If I was to see a sea helium-3, what would it look like?
I don't know. I've never seen it myself.
Fair enough. I wasn't sure if you would know or not. I was just interested in that. It's the first time I've kind of come across that particular subject, so I was interested.
Yeah, I should find out myself.
We'll have to find out. Yeah.
I mean, the idea is that you got to mine it, and the thing is, when you mine it, you got to mine tons of it. It comes out of the regolith. It's in the regolith, right?
Okay.
And you got to like extract it out of the regolith. And what I understand, it's like tons and tons of regolith has to be processed to get just small parts per million.
Okay, right. So it's probably small particles within the rock, effectively, is what it is. Yeah. Okay. So it's pretty a little bit similar to often how they mine gold a lot of the time when they get the rocks that have got sort of gold particles.
Pan for the gold, right? You got a lot of the slag left over.
Yeah, exactly. Okay. That makes some sense. All right. So where do you see the next 2 decades of space exploration? How do you see those panning out?
So I think we will be on the moon definitely with probably maybe a 50-person station of some sort in the next 2 decades. By 2050.
Okay.
And we'll start really getting into our stride with more of the infrastructure that's going to be required. The initial infrastructure you need to do is the landing pads and the power system.
Yes.
So this is where we play, and that's what we're doing is at Astroport. Is we're developing those very first steps of construction that has to be put in place for sustaining a base.
Yeah.
If you're going to land there,
how are they intending to power the moon base? What is the power system?
Solar power and nuclear power.
Okay.
As well, the administration just made a national space policy mandate that there'll be a nuclear reactor on the moon by 2030, and that's what we're trying to work with as well. Trying to show how do you actually get. We're not building the reactor. We're the civil engineers that are coming up there doing the surveying, the site surveying, and doing the soil mechanics to understand how this 15-ton reactor is going to be in place at an optimum location.
Yeah.
So that it is using the topology to protect the astronauts in their habitation zone from any kind of radiation, and building berms around it, and then building the haul road from the lander to the delivery of that location. All these things are like the basic construction.
Absolutely, and obviously there's obviously the added complication of the fact that there is less gravity on the moon. And you got
to deal with
all of that.
The machinery can't work the same way. On Earth, when we clear ground and level sites, and we rely on weight of these big caterpillars, big bulldozers and tractors. You don't have that there, so you have to do it. You have to do a different kind of a excavation process because you don't have the reactive mass to help you push dirt or dig dirt.
Yes,
and that's what we're developing. We're developing those kind of excavators that work on the moon by
It'll
scraping.
work in the lower gravity. Okay. And,
Exactly.
and are you aware of the kind of surface you're actually going to be dealing with? I mean, is it very rocky? Is it very sandy? Is it very, you know, what kind of actual?
Yeah, so that's a big issue because all we know is the Apollo samples that were brought back, right?
Yeah.
And the Apollos, you know, so we have a good characterization with that Mara regolith. Regolith is moon there when I say regolith. So that Mara region, but we're not going there. We're going to the South Pole. That's where the water is right now.
Right. Okay. So the water deposits on the moon are underneath the southern part of the moon.
Yeah, and that's a different kind of material. It's a highland. They call it highland regolith because it's got different compositions in it. So we have some ideas of it. We don't have, you know, we work with simulants here.
Yeah.
To try to compose the same composition of minerals that we think are in that type of regolith. We have some samples from, I think the last mission, Apollo 17, maybe brought something back from the edges of it. But those are, you know, but to your question, we don't have the geotechnics data to understand what are the soil densities, what are the soil mechanics that we need to design to as well. Yeah, that's what we need to do. Is the first mission is going to be a surveyor bot that goes and surveys that kind of stuff and does
absolutely those
densities.
Well, this is what I was thinking. You know, it was jumping into my head. It was like, you know, how do you plan on how to build something on a surface you're not 100% sure what it's even like? How do you do that?
Well, you need the data, and our CONOPS, our mission plan, is to first send a surveyor. We call it surveyor bot, which is a surveying robot that's going to go with the ground penetrating radar and other kind of node plate testers to do those measurements and send that data as well. Can they do anything? That's a precursor mission.
Yeah. Can they do anything like that with moon orbiting satellites? Can they not send satellites up to more with the moon and scan it out with LiDAR and things like that?
To some extent, but you don't have the real mechanical structure of the soil itself. The soil, the regolith is much different than what we see here on Earth in terms of the granularity of it. It's very jagged and very, very. If you go to the beach and take up any kind of soil sample here, it's all rounded, right? It's not because it's been weathered.
Yes.
Well, there's no weathering going on the moon.
Okay.
So it's like shards of glass. And when they get compacted, they'll interlock. So they get densely compacted sometimes. The top layer will be fluffy for the top 20 centimeters. It's probably because it's been bombarded over billions of years over the eons by micrometeorites. But all that compaction, then that layer on the top has been slowly compacting what's below it. So it becomes much more dense and over consolidated.
Interesting.
Over-consolidated means if you start digging at it, it might be a different kind of a reaction to being disturbed.
Okay, and so as you say, it's almost like a looser material, but it's the sort of sharp, almost glass shards kind of feeling to it.
Looser material on the top 20 centimeters or so, and it's all shard and angles and at the granular level, right?
Okay, so I've seen some stuff about the moon that has always really fascinated me, which is one of the conspiracy theories around the moon is that it's hollow, and it's because from a size to sort of ratio perspective between us and our moon, we're the planet with the biggest moon by ratio to size of our planet that we've ever discovered. And the moon, if it was the same density of Earth, would effectively fling us out of orbit if it was the same density as Earth. So there's a lot of theories around why that is. Is it less dense? Has it got different materials in it? Is it hollow? And one of the one of the Apollo missions, they crashed things into the moon and then recorded the seismic activity that happened, and it's very and the seismic waves actually sped up inside the moon and things like that. So we're giving them the intention. There's either very, very low density material or even hollow cavities within the moon itself. So do you understand, or is this the kind of stuff that you guys are looking at and working out as well, or are you only interested in that particular surface area at the moment?
Well, only to the extent that it affects the foundation that we put in. We have to deal with moonquakes. There are substantial moonquakes.
Okay.
That right, not to the extent that we have here on Earth, but they are there, and we have to deal with that. So
okay.
So
there's seismic activity going on under the surface of the moon as well that's causing moonquakes too.
Yeah, I mean, so now I've heard that the moon rings like a bell, so it's hollow. So I don't really. I think there's some geologic explanation for all that, especially since it's been. If you think about the lava tubes, for example, that have been discovered there, the lava tubes are more on the Mars side, not the poles, but they are. If the largest lava tube, or not lava tube, but a cave that we have here on Earth is Hong Dong Song Cave in Vietnam, in North Vietnam. It's almost like, I think, 48 meters in height or something, and that's thought to be this average size of a lava tube on the moon.
Okay,
even bigger. There's some studies that show you could put a city inside one of these lava tubes. So there's a lot of that.
Yeah.
During the volcanism period of the Earth, of the moon, that was all being formed back then.
Right. Okay. And obviously, because it's had a very different amount of gravity around it, and
the gravity is the cause of that. On Mars, the lava tubes on Mars are even bigger because of its 1/3 gravity. So there are, the gravity takes effect, when you start thinking about the formation of the geology of the planets. Absolutely. Again, I'm not a planetary geologist. So I'm not.
No, it's still fascinating to think about these things. And I'm not asking you to come up with answers to questions the answers to. I'm just interested to kind of dig into these subjects, because they're really fascinating. So, okay. The next step from the moon is Mars. That's the plan, and the reason for that being that Mars is the closest planet to us that we could actually have a chance of landing anything onto and potentially surviving on. I think the surface of Venus is completely inhospitable, and no point is trying to put anything on it, as far as I understand. So that's why Mars is the target.
So there were studies. There's I guess a couple of studies that showed maybe put it above the clouds. There was some study about building above the floating cities above the clouds of Mars. It's science fiction, but
okay.
If you want to go to Venus, you live above the clouds.
Yeah, you can't. Yeah, you can't be living on the surface. Yeah, exactly. So Mars is the next one. So are the considerations that you're looking at for construction on the moon comparable to the ones on Mars?
Yeah, to some extent, yes. I mean, that's kind of the mantra right now, is that use the moon as a proving ground for how do you build on another planet, and how do you and understand those processes. Certainly, a lot of the construction aspects would be comparable in terms of what you need to do, and to again build the infrastructure, build the landing pads, and use the Martian regolith for the for the building material as well.
Yeah.
So those things are all transferable, of course, definitely.
Okay, so is part of the intention then, when you in Mars, that they're intending to actually sort of quarry things to build on Mars with stone, with stuff from the surface, rather than shipping it all over there?
Oh yeah, definitely. I mean, it's the only way you can do that. It's just cost prohibitive, and to bring all that weight with you. Yeah. And aerospace weight is the thing you're always trying to
keep as low as possible. Yeah, exactly. Yeah. Reducing.
So it's living off the land. It's the idea is you live off the land, just like they did when they came over here to the to the new world. they built sod houses out of the mud that was in the plains, right?
Yeah. They didn't take all the building materials to build houses with them. They went there and used what was there. Yeah, that makes sense. Okay,
so it's the same principle.
Okay.
The regolith, on both Mars and on the Moon, has got a lot of useful material within it. You can extract gases out of it and metals out of it, titanium, iron, sulfur, all kinds of things can be processed out of the moon dirt.
Yes.
So build materials.
On that note, though, with the rare earth metals thing and stuff like that. Obviously, we're in the sort of venture capital space quite a lot of the time, and so a lot of what we're looking at is the actual economics of these things. And I think we talked previously when we spoke before about these companies that are looking at doing asteroid mining and things like that. But when you actually calculate up the cost of getting there, mining it, putting it into a way you can ship it, putting it into and then being able to bring it back to Earth and use it. By the time you've done that, you've increased the cost of it potentially 2, 3, 4 times over, and therefore it becomes actually less viable as a result. I mean, what are the economics of that kind of thing on the Moon, as far as you're aware?
Well, the only thing that I am aware is proposed to be exported back, okay, for use on Earth, is the helium-3 piece of it. All the other stuff. Now, I say rare earth metals that you would find on the Moon. That's not really been all that proven yet. The idea is that here on Earth, where you see the mining sites at there's probably close to some proximity of where it had been at one time an asteroid had hit, right?
Yeah,
and that's where you see a lot of the minings around these asteroids,
where the asteroid craters are. They can sort of look at the surface of what's been thrown out, and kind of figure out what's under the surface.
Yeah, so that's kind of the same thing. You would see if all these asteroids may even hit the Moon, of course. But really, the only mineral that I know of that's being proposed to be extracted and exported back to Earth is the helium-3 mineral.
Okay.
The other stuff is being used there on the Moon's lunar surface for the furtherance of the development of the economy, the lunar surface, and the fuel, the water part as well.
That would make sense. I see that. I see what you're saying there. In terms of, we're not intending to go to the Moon and go to Mars and ship all of the resources back to Earth. We're intending to go there and for the most part use them on those locations to allow those locations to be to be self-sustaining.
Self-sustaining, exactly. Yeah. Now, who's to say you're not going to find something that could be used very useful? A rare earth mineral that becomes needed as well.
Yeah.
So that's after we do the exploration. Find the reserves.
Of course. Okay. So, where do you see the future of it going? Let's jump forward 100 years.
Oh, 100 years from now, I see us with probably living in the lava tubes I mentioned earlier. Developing those lava tubes are real important as a habitation area because they offer protection from the radiation environment, from the night day cycle of the Moon. You can design your materials and all your structures without having to worry about the thermal variations between day and night temperatures.
Because it's extremely cold at night on the Moon because there's obviously no sort of ground heat source on the Moon effectively. So
and you have a 2-week cycle. It's always changing from extreme temperatures. Inside the lava tubes, it's a consistent environment. It's a benign environment that takes us down the order of -20 C. So the lava tubes are going to be important in the future, I believe, for long-term stay, and you'll have as much activity on top of the lava tube as you will below the ground. Where you're living
so a lot of the living on the Moon might be subterranean.
Exactly, and then also I see you want to get eventually out of the cans, out of the modules, and out of the spacesuits. So you would probably cover the tubes are down low. Where we know the tubes are at that mostly at the bottom of a pit, a skylight they call it. It's the collapsed skylight. So it's the collapsed part of a tube that's been it opens up the entrance to the tube. And those sometimes they're 100 to 60 meters deep, these tubes. So you got to get down in there. That's a big problem. But once you do that, get all the technology, you have that all done. I'm talking 100 years from now, right? Okay. Well, so that got lots of technology, lots of material development going on. Yeah. So you start you'll cover those holes, those pits. Now you have domes over them. You pressurize it. You got some kind of material that keeps the permeation of the gas from escaping. And you get yourself out of the tube, and you're living in a regular environment where you can walk around without spacesuit. So.
That is interesting. And then and would you expect that they will ever end up with would you expect you would ever end up with permanent residents on the moon?
I'm sorry, what, with urban residents?
Permanent residents on the moon.
Urban
people living there all the time.
Yeah, I think so. In 100 years from now, I would think so.
Yeah. And we would expect maybe that within that time frame they're figuring out how you would overcome the muscle atrophy and bone density issues. So obviously, the moon's gravity is what? It's about a quarter of what the Earth's is.
1/6 of the Earth. So it's not as bad. Okay. Yeah. You'll have better. Again, we're talking 100 years from now, and we're you can actually use the gravity to your advantage for doing different kind of sports.
Yeah.
Think of basketball, right? Once it's gravity.
You can probably hit a golf ball a long way as well on the moon.
Right. So probably 100 years, maybe. I think it'd be a 100-person settlement. That'd be a conservative estimate.
Okay. Wow. Yeah. That's cool. That is cool. Okay. So I always want to get into in these podcasts, what I'm really interested in is what this means for the future of humanity. What does establishing a moon base do for the future of humanity?
Sure. So you think about it as another continent, right? And you expand the GDP of the nations that are there, because it's whatever you're doing for building on the moon in terms of materials and technologies and the new advancements, it's all going to come back to Earth, because it's being developed. For the space has got a historical 7-to-1 ratio in terms of investment, right? For every dollar you invest in space, you get 7 times return of those technologies. Okay. And this is the same thing here. So we're going to be learning new materials. Okay. New ways of doing autonomous robotics, autonomous construction. All these processes are all going to be redeployed back on Earth. But at the same time, and these are companies building materials and building machinery, building AI, and building all kinds of communications and power systems that will be directly transferable back to usage back here on Earth as well. So you're developing this economy that is expanding the economy of the countries that are there. The gross domestic product of the United States is going to be expanded, X times, it is currently right now.
And are there going to be territorial disputes on the moon then?
Potentially. Yeah. Because right now the big thing is beating the Chinese to the moon. And so the Outer Space Treaty. The Outer Space Treaty, one of the first, the Outer Space Treaty.
I think it's the Outer Space Treaty. Yeah,
right. It prohibits anybody claiming celestial bodies, right, for them, for national stuff. But the way they get around this is that if you land somewhere and you start setting up a base of some kind, all your assets are there, right? So by landing, they can say this. We need a keep out zone. You can't land close to us, because when you land, you're going to destroy all the sandblasting of all the rocket plume and stuff. Will come and destroy everything we got there. So they say, just for our safety reasons, it's a keep out zone. Yeah. So that's essentially it's territorial graph.
Yeah, you end up with sort of regions on the moon controlled by different nations, effectively, and then you've got the same thing that you have here on Earth.
Yeah. but they don't own it. But they can claim the activity that they're doing there is needs to be secured and safe. So
yeah, and I suppose once you're at that point, because at the moment the big race in the world, as far there's always like there was the nuclear arms race back in the 50s through into the sort of 60s, 70s. That was the nuclear arms race, and then now we're in the AI race, and that's the big thing. So, but the space race is kind of almost hotting up quite significantly now as well. That's a big part of it. Obviously, they had the brief space race back when the US went and landed on the moon first of all, but that kind of died away after that. So the space race itself, do you see that being symbiotic with the AI race?
Yeah, well, somewhat, yes, I think so. I mean, the AI races, involves data centers, for example, and the use of AI for advancing the ability to do technology development.
Yeah.
Data centers, right now the big deal is data centers in low Earth orbit.
Yes.
Eventually, going to be data centers on the moon in the lava tube caves. Because there's a lot more, you can a lot more protection from them as well. You can, there's the radiation. I'm sorry, the heat rejection of all that stuff can be.
Well, yeah, it's a lot colder, isn't it? So you don't have the same issue as opposed with trying to cool them as much.
Yeah, right. Yeah, exactly.
Yeah.
So okay. I think yes, the answer, and I think that's going to be. I think we're already planning for contested space. The forces are the armed forces of China and the United States. You see a lot of this happening with the Space Force being stood up, and I foresee at some point we'll have a Space Force construction brigade, just like the Seabees or the U.S. Corps of Engineers.
Yeah, they
Space Force will have their own construction brigade for setting up outposts. Right now, the military is prohibited for being on the moon. But I don't know how long that's going to last.
Yeah, how long that lasts. Or yes, as soon as you end up with
once you have commercial interest right there, commercial interest on doing mining and stuff, and they're going to want protection from some sort of adversarial country.
Exactly. So
encroaching on their claims, right?
Yeah,
it's like the cavalry in the old west, Wild West, right?
That's it.
The cavalry had the forts, right?
That's it.
So it's going to be the same. That could be a future. I don't know if it will or not, but that's a possible future.
That's it, and I think that's a really fascinating thing to look at, and
so the other thing too is that even the national security of this is important because the moon's national security interest, because once you get into deep space, you want to have eyes and ears on your adversaries, right? In deep space, so that means large aperture satellites, huge satellites that need to be built. But where's that material going to come from? It can come from the moon. So now the moon, now you're exporting. Now that would be what would be exported out of the moon is these materials that we're building on the moon, or developing on the moon, or processing or manufacturing on the moon, can be then exported for building huge satellite apertures that will have eyes and ears on somebody on China that's on the other side of the moon and doing there. We don't want to know what everybody's doing all the time.
Yeah.
Sure there's nothing bad.
Yeah, it's everywhere. Everybody needs to know what everyone's doing all the time, obviously, to make sure that no one's trying to do anything they don't agree with. That's always the way, isn't it? Okay, so let's. In your opinion, and I appreciate, again, I'm not, and it'll be a long time before we find out if you're right or not. But in your opinion, how far away are we from a Mars base?
Oh, a Mars base, a base was actually people staying there, living there. Yeah, I think we're probably 20 years away from that.
At least, or
at least,
okay.
at least 20 years away.
Yeah.
Although if Elon gets his way out, he kind of focused his attention back to the moon. Recently. But
I think they've, as far as I understand it from listening to what he's saying, the reasoning that they've decided to refocus their attention on the moon is because it's integral to getting to Mars in the first place. They kind of need the moon as the jumping off point. And so they need to go to the moon first and then launch from there to Mars. That's as I understand it. So I don't believe the focus is off Mars, but I think they've realized that going from Earth to Mars is a lot more difficult than if you go from the moon to Mars.
Yeah, there we go. Yeah.
And what about more, even deeper deep space travel?
Well, I mean, what's the next? I think Europa is being looked at as another possible planet that could hold habitation.
Yes.
Yeah. So I mean, Europa or one of the planets around Jupiter.
Yeah, a few of Jupiter's moons are considered. I think Europa's definitely one. I think. What's the other one? That's Titan.
Enceladus, I think. Enceladus
I think Titan might be one of them as well.
They think it's kind of ocean.
Yeah.
Although they discovered it might just be a methane ocean kind of thing.
Yeah, exactly. That'd be disappointing if you got there thinking that it was an ocean full of water. You discovered all that it's full of methane. So how long, honestly, do we think it's going to be before the human species is genuinely an interplanetary species? And by an interplanetary species, what I'm meaning is that we have settlements on multiple planets that we can travel between relatively easily, similar to the way I can get on a plane and fly to London or Sydney or something like that. How far away is that?
I think again, we're end of the century at least. For that.
And these things have a way of moving a bit slower than you'd expect as well.
Yeah, and but they also can move faster too. If there's something, if there's a golden, and there are hills in the hills. They'll get there faster.
Yeah, people find a way. Yeah, exactly. When there's as you say, when there's the right financial incentives, people will find the way to make it happen and find the way to make it viable. I think that's the ultimate. That is the ultimate good in human property rights. In the if you incentivize people, like anyone who can is able to go and find another place to go to and can exploit that into turning that into money that comes back to them. That makes
sense. The technologies there. You got the technology. Space technology takes a long time to develop. Okay, a lot of times 10 years or so before you get a good tried and true, reusable type of technology. Yeah. So those technologies take time to gel. That's why when I talk about through my company, we're developing lunar construction technology and stuff. We got to start now. It takes a long time for it to mature and to prove out.
Yeah, there's a lot of unknowns in space as well, isn't there? There's a lot, as you were saying with regard to the moon. You don't know exactly what that surface is going to look like. You don't know what it's going to look like when you drill down 20, 30 feet. You don't know what it's going to look like at 100 feet. You don't know what these things are going to be like. And so and so as a result of that, there's going to be false starts. There's going to be there's that, plus also the politics involved. A lot of the reason it's taken 50 years to get back is it's all the politics involved. The will of the people, the funding part of it. There was no interest in going back to the moon in the 1980s, was there really?
I pride myself actually. I did predict the future one time about this. In 2013, I did a SpaceX talk. A TEDx talk.
Okay.
Predicting about this current decade, what's going to happen this decade especially with Elon Musk at Brownsville, Texas. He's going to build a base there. Houston is becoming a mecca for human space travel. Well, that's happening right now. Houston and Texas in general is making a big play for space infrastructure for the state. Resources the state has to offer for companies that are developing new companies, commercial companies that are developing technologies. The state itself is investing in resources to have that occur.
Yeah.
And that's what I was saying back in 2013. That it'd be, this decade, by starting in 2023, you see all the stuff happening, and it is happening.
But I think it's very noticeable, isn't it, that the movement in space kind of commercialization, and as a result, far more interest and opportunity in space has come about as soon as it's become possible for private individuals to start making real money in that area. Because I think previously it was almost like it was the purview of government funded organizations like NASA. And as everyone knows, anything that's government funded, runs inefficiently, costs too much money, and doesn't ultimately end up doing a particularly great job of anything that it does. Not to say that NASA didn't do some good things, but as soon as you put that in the hands of commercial entities, it tends to accelerate exponentially.
Yeah. I might take the example of the NASA's latest rocket, the SLS Space Launch System. $1 billion to launch for one, then it's not reusable.
Yeah, exactly.
Versus Elon Musk,
Yeah, and SpaceX are doing it for less than half of that, and they're making them reusable and repeatable. Yeah, exactly, because again, they've got the commercial incentive to make them reusable.
Yeah, and they drove the market. They drove down the cost of launch, which in turn allowed this current era we're in of commercial space companies now have. It's cheaper to get to space, right? So now there's all kinds. So right now, the biggest investment that you see going on in space is in low Earth orbit. You can launch satellites into space, and they can be repurposed or reused or even thrown away and put another one up. It's cheap that way. Yeah. And so you see a lot of companies doing a lot of remote sensing business cases, and and data center is another reason they're trying to go.
The data center is a big one, and we were. I was talking to a company fairly recently. They were trying to put satellites up for forest fire early detection, things like that. There's all these
kinds of things. Yeah, there's just a myriad of applications that the satellites are being able to bring us new services as well.
Yeah, and again, it's when you open it up to commercialization. I mean, I was having a conversation with somebody the other day, and they mentioned about, like, how did Britain, this tiny little island, invade half the world with and build the biggest empire that's ever existed as far as landmass goes, and the reason was commercialization. It wasn't actually built by British armies marching across lands and invading countries. It was built by private organizations who were going out to establish things, and then they brought the military along with them to protect it.
Was the trading company? What was it called?
The East India Company.
East India Company.
Yeah, they were the ones that did it. They founded something like 15 cities. So something like 15 cities in the world today were founded by the East India Company. And at the time that they were at their height, they were the most valuable entity on the planet. They had more money than any government on the planet. They had their own navy, their own army. They made more money than any other entity on Earth was making. And that was all. It was all commercial. It was the British Empire was built on commerce. It wasn't built on conquest.
Well, it's exactly the same thing. I mean, of course, the army was there. The British army was there protected, right? To protect the interests of the
exactly. Yeah. That's what happened. Yeah.
This is what I was saying earlier. That you're going to have commercial interests. Then you're going to have the Space Force there to protect the interests.
Protect the interests. Exactly. Yeah. I think that's the way it's most likely to go. There's not that much utility in the modern era in invading a country just because you can. There's that used to be the way that the world worked for the last however many thousand years. It was, that we
want Putin about that.
Yeah, we want that piece of land over there. We don't particularly like the people there. We're just going to take it. That was how it used to be. Nowadays, there's not that much utility in that. There's not really a lot of reason for a government or a country to do that these days. But the commercial side of it makes an awful lot of sense. There's all the stuff around Cuba at the moment, and what's going on there, and I think that it would only take the right commercial interests to say, look, help us get the government out of Cuba, and we will turn it into the paradise it could be with all of the holiday stuff that you could have there, and all of the
back before Castro came in, took it over.
Exactly. Yeah, there's all this stuff we can do with it, and it suddenly becomes a much more viable thing to do. But as long as there's no commercial viability in it, there's not really a lot of utility in governments bothering with it.
Well, it'd be the same thing with space. So that's the cislunar economy. When we talk about cislunar economy, that premise holds true as well.
Absolutely. You can almost look at SpaceX as the space version of the East India Company. They're the ones that are doing that first step out, and they're leading it with the commercial approach.
Except that they have a lot of government subsidies.
Yes, well, a lot of people have government subsidies. I think even the East India Company's early days had quite a bit of subsidies to give to it as well. But
we're still at that stage where we need to rely on the government as a catalyst for these big plans.
A lot of
but eventually you don't have they'll become they are the anchor customer right now. But eventually, the goal is to get. You don't need them as the anchor customer. There's a multiple number of customers. Government's just one customer of many.
Yes. Well, exactly. I mean, you'll be aware, how much private money is now going into space and into space exploration, and how much investments are going into those areas. And there's several space-focused venture funds based in Texas themselves. There's several groups in Texas who directly focus on space exploration investment.
They're all over the world. Not just Texas.
All I mean is that Texas is probably the kind of one that's the creative area of the world that's kind of leading the way in that at the moment.
I think so to some extent. In terms of the funding, venture funds. Although there's a good one there, a big one there in Seraphin. I just saw they're in the UK. Just announced a new fund, $100 million fund for space.
Yes, I saw that one as well. Actually, I was reading the LinkedIn article about them a couple of days ago. I think I saw that one. So it's a really interesting space to consider, and obviously I appreciate space and space being the space as it were. But there
are a number in Europe. I mean, in general, there's always springing up. I see it here, new ones all the time in Europe springing up as well. In Asia, in Japan, as well.
I think the commercial element of it can no longer be ignored. I think that's what it is. For the last sort of maybe 40 years or so between the last moon landings and up until the last sort of 10 years or so, there wasn't the same fervor of commercial opportunity in the space sector. But now there is.
And why is that? Because of low cost access to space.
Yes. Pioneered by the mission to try to get to Mars by a private entity who looked to try to push the cost of getting into space down.
Exactly.
I
mean, the reusable rocket was. I mean, it was. You think about it. The argument that why would you fly a jetliner one time to your destination and throw it away?
Exactly. Exactly. I know, and it just makes a load of sense the moment you spend more than 10 seconds thinking about it. Well, of course you'd want to be able to use it again and bring it back, rather than just drop it into the atmosphere and let it burn into nothing. Why would you do that? You know, it makes a lot more sense if we can bring it back. You know, that's you know, and I think that is ultimately always the way that it was going to end up having to go. You're never going to actually be able to achieve it with single-use spacecraft. It's just not going to be able to ever be particularly viable that way.
Yeah, and you see the companies that are doing that, they're dropping out. You know, I mean, everybody, even China is developing their own reusable rockets, and now he's getting a little bit more competition now from other companies. Developing as well. And not just rockets. I mean, we've got other ways of getting up in space. There's single stage to orbit spacecraft being developed, but not as much capacity as the Starship does.
So I want to ask a particular question here about first phase colonization of Mars. In as much as the first people that go there, the first people that ever fly a manned mission to Mars, based on existing technology and what they're working on and what they're trying to do you think the first people that go there will be able to come back? Or do you think it's more likely that the first people that go there are there?
So what's the mission? Is the mission to go there and stay there, or is the mission to go there and explore on the first mission?
Yeah.
So if they're going to settle, and stay there, they probably won't come back. But somebody's going to die. Somebody's going to die.
Yeah, of course. I think that's without question. I suppose what I'm really trying to ask here is: are the first missions out there going to be a little bit? Because the biggest problem that I can see that they have is being able to fly something there that they then are able to use to relaunch back out of the atmosphere of Mars and get back, because they've got to take an awful lot of fuel and resources with them, or they've got to take something with them that they can use to get hold of the fuel there and refuel something that they can then fly back with. And at the moment, as far as I'm aware, there's no actual kind of exact viability in that at the moment.
Not at the moment. I mean, that's what they need to do. They need to have a pre-positioned material and pre-positioned, technology that's going to be able to produce the fuel that they need to have to return. Right?
Yeah.
So, and that's not. I mean, that's all on the drawing board. Still being developed and all that. Like I told you, it takes a lot of time to develop space technology.
I am certain that it does, and as we say, you're working in theoretical mathematics a lot of the time, and they don't really know all the answers, and there's always the possibility that when someone's on Mars, which is you will probably know this answer, at its closest, how far away is Mars?
About a 6-month journey.
Yeah, but in terms of
astronomical units, I don't know that.
I think it's about 2 or 3, if I remember rightly. So it's somewhere around, about 200 million miles away ish, I think. Now, so if that's when it's that's when it's at its closest to us, and then obviously when it moves around, it's further away. So even at its closest, it's 200 million miles away from us. If something goes wrong, you're 200 million miles away from home, you are as on your own as you can possibly be.
Call 911.
Yeah, exactly. There's no one that's and the time it would take for them to send people to you to help is going to be very hard, unless of course they've already pre-prepared a team ready to go if there is a problem for them still to go out there. It's still going to take a minimum of 6 months for them to get there. So it's a long way. I'm actually going to ask the question. I'm going to ask AI the question how far away Mars is, because I want to understand that. So let's see what it tells us. So at its closest, how far away is Mars from Earth? So So at the moment, so at its closest, it's 34.8 million miles. So
34. All right.
34, that's its closest. But it moves, and at the moment, January 2025 was the last measurement it's got here. It was 96.1 million miles away. So it obviously moves continuously, but it looks like the closest it's ever been as far as they've recorded was 38. But most of the time it's somewhere between 55 and 100. so
those are millions of miles.
Exactly, those are millions of miles. Yes, exactly. So it's a the theoretical minimum due to elliptical orbits is around 54.6 million kilometers or 33.9 million miles. Although that's never been recorded. they've never really recorded
that's a long ways away from home. And
that is, and this is it. As soon as something goes wrong in one of those environments, that's it. And as you say, it's a minimum of 6 months before someone gets to you, and that depends where you are in the orbit when it goes wrong, how far apart we are when that happens, and so on. So whoever does that first journey are a bit like the people that sailed off on Columbus's ship across to across the Atlantic to America. In that you're kind of just going, we may never come back. You've got
that's the mindset you got to have.
Yeah, you've got to have that mindset. It's a really it's a certain kind of mindset of people that has to do that, and there you go. And at its furthest apart, about 250 million miles.
Oh, wow.
So when it's at its furthest, it's 250 million miles.
So have you seen the program, The Expanse?
Yes, I have. Yes,
I think that's probably one of the more that one. I mean,
more realistic one.
Futuristic. If you're talking about interplanetary travel and going back and forth, catching a plane. That's what that's about. There's another one called For All Mankind. That if you heard of that one, that's got an alternative history to it, where the Russians won the space race.
Yeah,
and that program, probably more not in terms of the storyline, but in terms of the technology and how they show things being used by the technology being used by the on the sets. That's probably more realistic than I have ever come across anything else.
Absolutely, it's been a while since I've seen that, but I do remember that some of the some of the technology that they're doing that it's still sort of connected to modern day technology in some way. Like it's sort of
it's connected to the Apollo technology in some way. Yeah, and it all works. It works very reasonable.
Yes, exactly. Yeah, and it does show that you can do these things with nothing, because there's a lot of evidence now that actually the Vikings made it to North America, and they rode that in longboats. They got all the way across there in longboats. Now, as far as we can tell, they went kind of Scotland, Iceland, Greenland, and then northern Canada and down.
They went around that rim.
Yeah, they didn't sail directly across the mid of the Atlantic, but they kind of worked their way across the land masses. But it still shows you can make very difficult, challenging journeys, even with very low grade technology that you wouldn't expect that you'd be able to make.
Yeah. I mean, humankind is just durable. Okay. I mean, very, very robust in terms of its innovations and the way they're doing things. It's amazing.
Innovative. Is when you think about it. What are the nothing else that we've ever crossed any path with. We won't go into the UFO conversation right now, but as far as we're aware, we are the only species that exists that actually even tries to do things like that.
Yeah.
you know, and that is a really it's the unique character of mankind that we want to explore and continue to go to those.
I mean, you're asking the question, why do we want to go to the moon? I mean, that's there you go right there. I mean, it's just our nature is to go explore.
Yeah, exactly. The nature part of it, I've never questioned. I suppose all that obviously always comes down to it is, what we know, you only keep going if there's a commercial reason to go.
Yeah.
I
mean, you keep going and keep going back. Let's put it that way.
Yeah. Exactly. Yeah. You only go there again if there's good reasons to keep going there again, and there's only a certain amount of exploration you do before you're like, there's nothing really here. We'll look for something else. There's certainly regions of the world. Nobody bothers these days, going out into the middle of the Sahara Desert for no reason. We know it's there. We know there's nothing there, so nobody really bothers going there anymore. And there's no commercial reason to go out there at the moment. There's the odd oil deposit and things like that, but that's a commercial reason to go to somewhere. But you're not going to get the center of the Sahara Desert being, large scale populated.
Robot metropolis, right?
Exactly, yeah. And until you get to robots, until you get to the stage where, I suppose that's a very interesting conversation to look at when we're looking at those kind of first phase explorations with the advances in AI and robotics. Is it far more likely we're sending exploratory robots somewhere first?
Yeah, I think so. You got. Yeah. I mean, that's kind of the thing we do here is especially when we talk about latitude. We have a whole scenario of our latitude exploration where you send the robots to do the exploration, do the characterization of the site, and then you send the robots and the humans with the together. Yes. The ground truth of the robots found, and then you decide whether you're going to come back to settle and develop it as well. Robots definitely have a place to go first, a place to trail.
Yes, exactly. Yeah. I mean, I think that obviously we've already sent the little Mars rovers and things out there to take a look around, but they were in comparison to some of the robotics that are being developed these days. Those are incredibly primitive machines in comparison to the stuff that's going now, and it's the same with when you look at the Apollo missions that took place in the sort of late 60s, early 70s. They're incredibly primitive machines in comparison to what we'd be using now. But I suppose what I'm asking is, do you think it's AI that's going to lead that first wave? Is AI going to be the first thing that actually travels to other planets and actually goes and checks them out and says, yeah, this is what we think it is, this depth is what we think, or this particular surface is not the right surface, and things like that, because it's there's less risk on human life?
Yeah, I mean, it certainly looks like it's moving that direction. AI is, starting to do a lot of things that, but the AI, you always have to validate it. You got to check it. You can't really rely totally on it. No. But at some point, though, maybe you'll have more confidence in it for the lunar or Mars mission, telling you what's found. But humans are going to need to be used always a part of be part of the program, just for the validation of what we're finding there.
Yeah, absolutely. Okay, and final question for you before we wrap up here: where do you see the biggest breakthrough coming in space exploration technology? What is the next big breakthrough that allows it to become far more accessible?
For accessible, in terms of accessibility for in general, getting to some direction. Well, propulsion is always, accessible. There's always propulsion that needs to be dealt with in terms of for long distance travel. Nuclear electric propulsion is one of them that could be used as well.
Okay.
As far as habitation,
uh
breakthroughs there would be again in construction technologies.
Okay.
We don't know how to build. Okay, build on the don't know how to build.
Yeah. Yeah. So it's figuring out
on
how
another planet.
Yeah. Yeah. So okay.
I mean,
right.
we know how to build, but not on another planet and all those things that go with it. So.
Yeah. Yeah. And obviously, I suppose there's always going to be the thing you touched on the sort of the thruster technology and things like that in terms of when we're able to find ways of traveling much faster through space. That I think is going to be one of the biggest ones, because it's going to reduce again the lag between going and finding out the answers and then coming back and then changing what you're doing and then going again and so on. Because if you think about it from this perspective, if you're flying to Mars and you fly out to Mars, you picked a site and you fly to the site and you land on the site, it's not viable. You can't use it. You can't do it. You've got to go back to the drawing board, and everything's all got to go back to Earth. You've got to redo everything, and you've got to fly it again. That whole process could take several years. Whereas if you're able to travel faster, you can really truncate that. Are you aware of anything that's happening of any real significance in that space?
No, I don't really know who's got the leading edge on that. I mean, there's definitely a lot of companies there's a few companies, more than a lot. There are really a few companies that have been trying to develop that technology. But I don't know who's got the leading edge on it right now.
Fair enough. Well, thank you so much, Sam. Real pleasure to have you on. It was absolutely great to do this, and we'll definitely talk more. I'm certain, because this is completely fascinating.
Appreciate the conversation, and I like your cigar and the nice atmosphere going on.
Thank you. It's kind of a little gimmick that I do. I always smoke one in every podcast. People remember it. So that's part of the reason. So before we go, tell everyone what your company is and where you're based and what you're focusing on right now.
Yeah. So the company is Astroport Space Technologies. We're based in San Antonio, Texas. And we're focused on lunar construction. We're actually building the robotics and the brick making. We actually take the dirt and we make bricks out of it to make the landing pads. So we're developing those technologies that allow us to actually do all the stuff we talked about, the very beginning stages. Okay, you got a journey of 1,000 miles is the first step. And to us, the first step for construction and building is learning how to use the living off the land. So.
Excellent. Well, thank you very much again. Thank you, and thank you everybody for watching. Please do reach out. I'll have tagged Sam and his company and so on in the description of this video. So if you'd like to reach out to him, speak to him directly, please feel free to do so. And we look forward to seeing you all again in the next episode. Thank you.
All right. Thanks, everybody.